Okay, first of all, I want you to give me a show. I want you to self-assess how you did. Okay? Either a thumb up positive, thumb down negative, or I don't know. Okay? I want you just get it right in front of you. I want to see how you think you did. Let me see them. Okay. All right. I just want to see where you think you're at. Now, what we need to do is we're going to go through and work these three. These are one of each type of an equation that we've already done. One of these is a single replacement, one's a decomposition, and one is a combination. So the first thing that we need to do, okay, the first thing, and if you cannot name or write this formula, I told you way back when, if you don't know your formulas and your nomenclature, you're going to struggle throughout the year, for the rest of the year. So, as I do this, I need to write my formula for lead 2 chloride. Lead 2 chloride is going to be heated. So I draw my yield and I put my little triangle to say that I am heating that. Now, the first thing I need to do is decide what type of a reaction is this. I think about my 5 types of reactions, of which you only know 3 of them, and I say, okay, this is not going to be a decomposition reaction. Would you agree with me? So, it's going to be a decomposition. Specifically, what number decomp is this? Number what? Number 6. It is just the decomposition of a binary compound, and it tells me that it gives me my 2 elements. So, it's going to give me lead. Do I need to signify which lead? Absolutely not. And it's also going to give me chlorine. But remember, chlorine is a super 7. Did you remember chlorine was a super 7? Remington? 2Cl is wrong, because you didn't put chlorine as a diatomic. Alright? What he's saying, instead of having Cl, he has this. Okay? Which would be wrong because chlorine is a diatomic and exists as Cl2. It's not found naturally on its own. Okay? It's found like this. Is that balanced? Yes. Okay? That's the first one. Calcium oxide reacts with water. Calcium oxide with water to yield. What type of a reaction is this? This is a combination. And specifically, it is combination number what? Combination number 3. So at least we're finding the right places where we need to be. Now, as I go on combination number 3, it says an active metal oxide. What does that tell me? Active metal oxide. It's got to be group 1 or 2, which is right on your outline, correct? Is calcium a group 1 or 2? Yes. So I meet my specifications. So an active metal oxide plus water liquid or cold, like I said, we're going to assume that this is a liquid cold water. If it would say steam, wouldn't work. It would say steam, wouldn't work. But this is water, so it's going to yield a metal hydroxide. Well, my metal hydroxide is going to be calcium hydroxide. So Ca is a 2 plus, hydroxide is a 1 minus, so it's going to yield CaOH2. I go back through and I look. Do I have a balanced chemical equation? Yes, I do. Questions on the second one? Kyle? Do I need to put the parentheses with right here? Do I have more than one hydroxide? Then I absolutely need the parentheses, yes. Any other questions? What does number 3 say? Combination. Plus water yields metal hydroxide. Okay? So I knew it was going to be a metal hydroxide. I just had to determine what my metal was. In this case, my metal was calcium. I went back and I checked. Is calcium group 1 or 2? Yeah, it is. It's an alkaline earth metal, group 2. So, yes, it does fit my bill. Now, the third and final one we're going to work here has potassium reacts with water Now, what type of a reaction is this? It is a single replacement. Specifically, it's a single replacement number 2. And what does single replacement number 2 say? Go ahead, Maddie. An active metal plus water yields a metal hydroxide and hydrogen. Now, I need to check my activity series, right? To determine if that is an active metal or not. Well, there is a line that says reacts with cold water liberating hydrogen gas. There's also one that says reacts with steam liberating hydrogen gas. Am I dealing with steam right here? No, believe me, folks, if they were having steam, it said potassium reacts with steam. It will say steam right on there. You know that steam is hot water, right? So, am I dealing with steam? No. I need to make sure that potassium is above the line of reacting with cold water to liberate hydrogen gas. Is it above that line? Absolutely. So I know that this reaction will occur, so I'm going to get a metal hydroxide and hydrogen. What's my metal hydroxide? Potassium hydroxide. Both of them are 1s. 1 plus for potassium, 1 minus for hydroxide, and also hydrogen gas. Hydrogen is also a super 7, so I need to make sure that I have it as a diatomic. Go through, am I balanced? I am not balanced, am I? Okay? I can see right now that I have 2 hydrogens there, and I have 3 over here. So what I'm going to do is, I'm going to put a 2 here. So now I have 4 hydrogens, correct? On my product side. I'm going to have 4 hydrogens on my reactant side. I have 2 oxygens on my product side. I have 2 oxygens on my reactant side. I have 2 potassium on my product side. So if I put a 2 here, I have 2 potassium on my reactant side. Any questions on the third one? Brittany? If the question is on the first one, Brittany said on the first one, if I just have that instead of that, would I count it wrong? I would probably write in the triangle above it, but not count it wrong. But what you need to do, you need to make sure. Now, theoretically, technically, that's wrong. Because would that happen if I didn't heat it? No. So technically, it's wrong. Would I get that technical right now? Probably not. Later on, will I? Absolutely.